Alright guys, this is the first of two videos on solving application problems. It is the last part, the last topic in Unit 4, and then you'll have completed your first virtual unit, and that'll leave us with Units 5, 6, and 7 left to go, with 5 and 6 being the most review of last year. This was mainly review, as I'm sure you noticed. 5 is all about slope, solving equations, solving systems. 6 is solving systems of inequalities. So that's definitely stuff you did last year. Both chapters 5 and 6 will have application problems, and they're a little bit more difficult than this chapter. Unit 4 only ever had one variable. Units 5 and 6 will have two variables, which makes everything a little bit more difficult. So, although you can probably answer these questions a lot of different ways, and I'm okay with that, I will be following a very specific order, and that's also how I'm going to teach it. And so you can choose what works best for you. If you feel like you need to follow this exact order, if you can jump around and kind of do these and solve these your own way, that's fine. But the way I'm doing it will help set up next units where a guess and check method isn't as efficient. So either way, you always have to read the problem first. It's a silly step, but you got to make sure you do it. I do like to highlight important information. Sometimes I'll circle important information, underline it, whatever. Identify what quantity the problem wants you to figure out. So this is called defining a variable. When you define your variable, that's like you choosing what you want X to be, or what you want Y to be, or A or B or C or whatever variable. This is one of the most important things. This is where algebra is used in the real world. This is why a variable is able to do what it does. You let a variable represent something you don't know. Then you are going to use that variable to write an algebraic statement, solve the statement, and then because these are word problems, you do just want to write some sort of sentence or phrase. So, if any of you are Eagles fans, you would know the answer to this without even having to solve this, but not every word problem is this way. Last Super Bowl, and this is, you can tell this is a little old because this actually wasn't the last Super Bowl, this was a couple of years ago. But last Super Bowl, the Philadelphia Eagles played the New England Patriots. If the Eagles scored 8 more points than the Patriots, and the total points by both teams was 74, what was the final score? So we want to find out what the final score is. The final score here being how much did the Eagles score, how many did the Patriots score. And like I was saying back up top, you want your variable to represent the thing that you know the least amount about. Well, you know something about the Eagles. They scored 8 more than the Patriots. You don't know anything about the Patriots. So this is what I mean by defining the variable. I'm going to let X be the points scored by the Patriots. Now that I have that, I want to set up some sort of algebraic statement that can represent this situation. So we know that the Patriots scored points. We know that the Eagles scored points. We know if we add those two together, we would get our total amount of points. So the Patriots scored X points. The total was 74. That was something we had. The Eagles scored 8 more than the Patriots. So you're gonna bring this plus sign down, and then the Eagles were 8 more than the Patriots. Once you get to this step here, The rest of the way is very easy. You're used to doing this. This is why we had to solve so many equations to start this unit. X plus x is 2x. In the same step, I'm going to subtract that 8 to the other side. 2x equals 66. X equals 33. And like I said, if anyone remembers the Super Bowl when the Eagles won, 33 was the amount of points scored by the Patriots. The Eagles scored 8 more than that, which means 33 plus 8 was the 41 that the Eagles scored. And so you could say something like the Eagles won 41 to 33. And that would be like your final sentence or statement. All right. We're going to flip it over. We're going to do 2 more questions. So, example 2 starts us off with one health club charges a $50 sign-up fee at $65 per month. Another health club has a $90 sign-up fee and $45 per month. You want to find out for what number of the months are they equal, because then this is where, like, legitimately you would do this, maybe not in the same instance I would, you would do a lot of this in your head, but you would do this out in the real world. You graduate high school, graduate college, you're trying to find a gym to go to, trying to stay healthy, and there are 2 local gyms. You're trying to find out which one's cheaper than the other one. And then you can determine, say they're equal at 6 months. Well, then you have to make the determination of, will I realistically last more than 6 months at a gym, or will it be more like 2 months and then I'll stop going? So we're going to find out when are these 2 equal. So we have health club, let's just call it A. We have health club A. We want to find out when is that equal to health club B. We want to know when are those 2 clubs going to be equal to each other. So what do we know about Health Club A? Well, it starts with a $50 sign-up fee. So I owe them $50 just to sign up. And then every month, I'm going to have to pay a fee. So I could let that be like 65M. So I'm going to let M equal the number of months. That way I can represent if I go 3 months, 4 months, 5 months, I can figure that out. That's going to be equal to Health Club B, which is $90 to sign up, but it's a cheaper rate. It's only $45 per month. Now I have an equation that I can solve. I like to have my variable positive, so I'm going to subtract the 45 to the left. In the same step, I'm going to take the 50 to the right. 20M is equal to 40. M is equal to 2. So at 2 months, they cost the same. So I can answer the question right now. The health clubs have the same cost at 2 months. Okay, that's the answer that I'm looking for. But if this were like a real question out in the real world, what you would be looking at is, okay, here comes January 1st. Happy New Year's. You have a New Year's resolution. I want to start going to the gym. Will your New Year's resolution last 2 months? If it will, if you think it'll be more than 2 months, then I'm going to Health Club B because B has a lower price per month. I'll be paying $20 less. I would go to Health Club A if your New Year's resolution is only going to last a month or less. All right, last question. Example 3 says, the sum of 2 consecutive integers is 175. What are the 2 integers? So these are the most common questions where students feel like they can find these out quicker than following the steps and the equations, and I completely understand. That's fine with me, but there are a couple of things I need to go over with you. First of all, consecutive means in a row. If you passed math in consecutive years, then that means you passed it last year and you're going to pass it this year. Consecutive means back to back. It's used a lot in sports, and when teams win championships. They're back-to-back winners. They've won consecutive NBA titles, something like that. So we need to realize, first of all, that, and this is why we talked about all the way back in the beginning of the year what integers are. Remember, integers would be like -3, -2, -1, 0, 1, 2, no decimals, no fractions. We can have some negative numbers, positive numbers, but I know I'm adding two numbers together and they're going to give me a positive number, so it probably won't be any negative numbers. It's going to be all my positive integers. But I know that the sum of two integers, well, I'm going to let x equal the first integer. All right, so I know I have a first integer plus the second integer is equal to the total. And the reason I'm adding them is because sum means to add. First integer is x. Now, this is the tricky part, and this is why I want to go over this one in detail, because you will see a question like this and it's going to be slightly different, so you have to understand what's going on here. First of all, an idea of consecutive integers would be 10 and 11. 10 and 11 are consecutive integers because they are right next to each other. 100 and 101 are consecutive integers because they're right next to each other. 1002 and 1003 are consecutive integers because they're right next to each other. So you need to find two numbers that are right next to each other. Well, if I know what the first one is, x, how do you get from 10 to 11? How do you get from 100 to 101? How do you get from 1002 to 1003? Well, you take the first integer and add 1. So this x represents the first integer. X plus 1 represents the second integer. Together they equal 175. Now I can solve. X equals 87. I added the x's together to get 2x, and the same step subtracted the 1. 187 divided by 2. 80 times 80 is 160. I got to get another 14. That's where the 7 comes from. So the first integer is 87. That means the second integer would have to be 88. Do 87 plus 88 equal 175? I hope so. They do. So you can write something as simple as this. The two integers are 87 and 88. All right, I'm gonna have another video of a couple more questions for you tomorrow. And then, like I said, this is a good pattern to follow: reading the problem, identifying the variable, solving. But like I said, a lot of students get very creative and can do a lot of this in their head, different ways, just kind of using a calculator. But next unit, when we start to do two variables, instead of letting x, we'll have like a let x equal, and then we'll also have a let y equal. And it'll get a little bit more confusing, and so you might want to follow this method. But until then, I know you guys are smart enough and creative enough to go ahead and work through the activity that I have for you today. Thanks for tuning in.